Welcome to this presentation. My name is Krzysztof Paruch. I am with the Institute of Cryptoeconomics in Vienna for around 1 year now. By training, I'm a mathematician. So I did my master's degree in technical mathematics at the Technical University in Vienna and at the faculty of ORCOS, Operations System and Control, and also economic department. What I would like to talk about today is economic systems engineering, so following on what Michael and Sherman were talking about before. And I would like to motivate and to start with a video, because who doesn't like a video in the morning? So what you're trying to do is, and I hope that it works here, I don't know, because we have some connection issues maybe. Does it? So what we want to do is basically this, but a little bit more sophisticated, I guess. Yeah. Okay. So you might be a little bit surprised of what I'm showing you here. So what you see is a machine, a robot, that is able to keep its balance even if it's torn in a specific direction. Why am I showing you this? Maybe another one. So let's talk about this motorcycle here. So you have this automated system that follows a specific purpose, even if it has outside influences it shocks. So why am I showing you this? Because we want to do this for economic systems, for digital economic systems, right? So what we have here is examples in robotics, where we are already capable of doing automated decentralized systems that have a specific purpose, which consist of subsystems that interact with each other. In the motorcycle example, you would have, for example, the steering, you would have the wheels, you would have the acceleration, and so on. And these subsystems are communicating with each other in order to fulfill one specific goal. So why don't do this with economics? And now we're talking about economic system engineering. So we want to borrow the methodology from complex system engineering. This is what Michael was talking about in the morning, and we want to synthesize it into the economic analysis. So we have the domain of economics, and we want to use the methodology from complex systems engineering. And how are we going to do this? We will start with a formal representation of the system. So we will have some kind of a model, we will make some assumptions, and we will start building something and talk about something that is given under these specific assumptions, that is right under these specific assumptions. We will use modeling and simulation in order to see how this thing that we talk about might evolve over time, and then we will be able to do some parameter tuning and to optimize this thing. If we look from the economic side, we will have to include social and behavioral components. We will also have to look at the market perspective, because many decentralized crypto projects, they very naively assume that there will be a demand for the token, but this is not very clear. And also we have to look at the investment perspective. So even in economics, you need to take different perspectives as well. So how does the design process look like? Is it possible to put this full screen? Sorry. Maybe.
Command Shift F.
Command Shift F. So the design process, which I would like to talk about, and I will base everything that I tell you today on. Is it?
No, it's not.
View, maybe? I don't know.
Yeah.
And the full screen, yeah, this one. Okay, thank you very much. So the design process that we're going to follow today and that I'm trying to describe is this one. So this is what we did for a project. A big crypto project approached us, and together with Michael and our economic professors, we did one specific economic system design that we were able to talk about then. Unfortunately, I cannot disclose which project it is, but what you can imagine is that it's a big proof of stake service provider. So what we need to tell them here is that they need to start with a system specification. So we need to define what are we looking at, and if we have this understood, then we can talk about the dynamic model. So how will the system change over time, and how will the economics of this model look like? And in this case, I use economics more in the sense of a business, right? So you have a service economy, so you need to understand the business of the service economy. If you have this, you can build a digital twin, which would be a digital representation of the system, in order to allow you to make simulations on this digital twin, and you are not required to make the analysis on the living patient. So this then would be a feedback loop back to system specification. So if you do the economic analysis here, you can feedback it into the system specification again and do this whole process all the time. So this is what you can do if you take a system modeling perspective. And after you have solved this, but we didn't do this with our client, is you can go into implementation, legal compliance, and the operation. And if you have the system running, you will then go again to use the digital twin again to make governance decisions, and so on and so on. So here you also see the full life cycle governance of the system. So these are two slides that show you the schools of economics. So economics is a social science that exists for around 250 years now. And as you can see here, and this is not exhaustive, you would have many different views that are sometimes contradicting, but that based on different assumptions and so on and so on. So if we wanted to talk to our economic professors and our economic staff at our faculties at the university, we had the problem that the people were saying, okay, which assumptions do you take? Which school do you apply here? So after we did this project with the client, we had the great achievement that the project team from the client side said, okay, now we understand that we need to hire an economist. And our economist said, now we understand what you are talking about. So this is what happened. And we needed to introduce them into these simple concepts of complex systems. So here, if you listen to Michael's talk, you will know what I'm talking about. But this is a complex system consisting of different subsystems that interact with each other. If you want to understand how the system behaves, you need to understand the boundaries and their interactions. You have a complex system that is dynamic, so time plays a role. And what you want to do is you want to control the path of the system. So if you have here a rocket and you want to fly to the moon, and you need to apply dynamic control in order to steer the system into specific directions. What you also need to do is you need to, if you want to model and if you want to understand the system, you have to look at it from different perspectives. And also, very important is the multi-scale approach. So if you model, you need to have different scales of modeling that are connected to each other. So you have micro foundations. Each of these layers is connected. So if you're talking about this, you need to know how this interacts with the layer above and the layer below. So this is the thing about complex systems. And if you talk about economics here, cryptoeconomics is, as I like to call it, economics on steroids. So what you see is that you want to define a purpose, a goal of the system, and you need to steer it into one specific direction. You want to attract the subsystems to behave in this specific way. Think of the motorcycle. The purpose is to stay upright all the time. But what happened in economics over the time, it was simplified. So it was a very complex environment, and researchers, politicians, and people who made the governance of the economies were not capable of making decisions decisions based on the limited data and based on the limited computation that was available. So they were only looking at the peak of the iceberg. But now, since we have computation, we can do exactly this. So we can construct economies that are digital, that are decentralized, and that are live steered by ongoing automated governance. So what is economic system engineering? We've been talking about cyber-physical economies. You have to think about this like this. So you define a digital economic system. So this would be basically the token economy. And you have agents, so humans or machines that are operating with this economy, right? So think of the Bitcoin network. You would have the users that operate within this system. But also they design it. So altogether you can call this the cyber-physical system. And what you see is that the digital economic system influences the cyber-physical system, which again is embedded in the whole economy, so it is embedded in the whole world. And what happens here also influences the economy as total, right? So if you, for example, we have in Vienna this purpose-driven token that is aimed to reduce CO2 emissions. So we design a project where we want to build a system for the inhabitants of Vienna who use it, and they will be incentivized to reduce CO2 emissions. And you would see that those people interacting with the systems would lead to changes in the economy or in the CO2 emissions in Vienna. So which methodology can we apply? And what we needed to point out in conversations with the client was that we need to take at least a three-layered approach. So we need to understand the economic system as a part of the outside economy. So whatever service economy they want to build, they need to understand how it is embedded and how it interacts with the outside world. May it be other crypto projects or may it be the real world. Then we needed to point out that this system that they are talking about is consisting of subsystems that interact with each other, and that each of these subsystems has some kind of mechanisms that, based on actions over mechanisms, lead to specific states of the system. These states can be measured then, and based on the observable measurements of the states, another actions are taken in the next step. So the first thing that we needed to do with them is to define the system goals, right? So if we have purpose-driven token, we also can have purpose-driven economies. And these, since we are talking about cyber-physical systems, we have technical goals on the one side and we have economic goals on the other side. So whenever you operate this service economy, you want it to be reliable, you want it to be secure, and you want it to be sustainable. So this is what you have to look at from a technical perspective. Because this is an infrastructure, it is mission critical, and it will interact with other infrastructures or other devices, so you need to rely on it that it's working. Here from the economic side, it's very intuitive. You want the system to grow over time. You want it to be price stable, so you want to be predictable. You want to operate the economy within some kind of predictability. But also the main goal is to create the value, the service that it has to do. So the first question we had was, what are the goals of your economy? And if you look at the bigger picture, so this is actually what you need to do ongoing if you are designing a complex system economy. So you need to start here are you are the humans, and you define the goals. So what is the purpose and what are the goals of the economy? These again will inform the economic conservation equations, the user role taxonomy, and the protocol and mechanism taxonomies. So based on the goals you have, you want to see, okay, what will happen or how to reach them, right? So what will happen if you do something or how to reach them. So on the other hand, you have the software, so you have the implementation. And most crypto projects start right here, and they believe that they are, I would say, like on the right track. But they don't see that they in reality need something like an information of this as well, which can lead into the dynamic system model that can be simulated based on observed data. And this then would make decision support software, operations and governance possible that would inform the humans in order to how to implement the system and also how to define new goals over time. So this is the ongoing process that needs to be done. So what is this dynamic system specification? So what is exactly this, right? So this is, maybe if you were careful and if you remember that I was talking about this here, then you will see that we will have this here as well. So you have the specific subsystems of the whole economy. So all of the lanes here down are the subsystems. And here you have the actions that can be taken. Here you have the mechanisms that would, over this action, lead to a specific state of the system. And these states can be measured, right? So you have metrics, you have KPIs of the system. And what you have here is the meaning of these boxes here is these are agents, so these are humans that do something within the system. These are stochastic processes, and these are controls that you can apply. Right? So what would happen is that you have a state of the system. You can measure it somehow. You can say, okay, what are you going to observe? What is the most valuable information for you? And based on this, these subsystems will make decisions, right? So think of the motorcycle again, and you will see, okay, if one of the subsystems sees that it's like the motorcycle is going too slow, then it will measure it here, and it will, for the next step in time, it will take one specific action that will lead to another state, or that will at least influence some states here. So this is what needs to be understood and needs to be defined in order to see how the economy would evolve dynamically over time. So once we had this, and this is what we reversed engineered with the project team from their protocol. So they were showing us this, and we reversed engineered this. So basically they've shown us their parts, and we've shown them their motorcycle, right? So this is what we did. And with this dynamic system specification and a paper about it, so how the dynamics evolve, we went to our economists at university. And what they said is, okay, this sounds similar. So what they have is, now let's forget the complex system. Now let's put on the economics hat. What we have here is economic controls. You have an economy, and you want to govern this economy to evolve over time, and you want to align the incentives of the individuals and community, and also it should be time consistent, so today and tomorrow. And what you want to do is that the economy should evolve over time according to set goals. And in our analog world, we have politics, we have law, and we have social sciences in order to ensure this, right? But in our digital economies, we can do this as well, but with more computational power. So economists told us that, okay, if you want to have this, you need to, as a society, define some goals. Then you would define or target these goals by policies. And the policies, they are not, so the goals are not directly reachable. You will have some kind of trade-offs because you can't have the perfect world. And if you look at this from a more scientific perspective, you could say, okay, how does this apply in real-world economics? So you have this economic system, which is this. Then you have goals for the system, and you want to reach them, but you don't know how. So you observe this economic system and derive some KPIs from it, which inform governance. And the governance is aimed to do something in order to achieve these goals. So the tools of governance are policies. So you can use this, policy A, you can use this, policy B, which is set to reach this goal here, which is set to reach this goal here. And what you can see is that you have trade-offs. You can talk, so economists like to talk about monetary policy and fiscal policy, for example. If you have an economic system, a market that has inefficiencies and shocks from the inside of the economy, but also from the outside of the economy, and that also trades within the outside world, in order to make the system, on the one hand, growing, and on the other hand, price stable, they apply monetary and fiscal policy that try to reach these goals. But they do this knowing that there will be some trade-offs. So you cannot have price stability and growth all the time. This might come at the cost of unemployment, for example. Economists also told us, okay, if you look at these token systems and how they interact with the outside world, you need to understand why there should be even demand for the token, right? Okay, 1 minute, I'm finished. So why there should even be demand for the token. So why should people assume that the service economy that someone would put working capital here in order to operate the service economy. So what you have here, what I want to point out here is that even if you earn something within the economy, if you do this, then you have inflation effects, for example, that mitigate your real returns, and then you have exchange rate effects that maybe mitigate your returns in the currency that you invested in. So what you really are interested in is the return on investment in the currency that you invest in. So for example, it could be Ethereum or it could be dollars. So it's not very clear that you will have demand for the token. So let's skip this. And also economists liked a lot that we have something like monetary and fiscal policy in these crypto economies as well. So what you can do like monetary policy most often is something like increase of the token supply that can be allocated to some specific purpose. And fiscal policy, what they like is some kind of collection and redistribution within the system. So they know these terms and they find them applicable here. So what are the overlap, synergies, and concerns? The concerns on the one hand is that we have some kind of terminology which is not consistent, and we have different assumptions that lead to different outcomes. That we need to take into considerations that all of these economies have naive assumptions and non-obvious simplifications, and also that the business perspective, the projects at an early stage are unpredictable. So it would be nice to have a business plan, to have an understanding of the market, understanding of the organization. What are the overlaps? So what do they like about this kind of things is that we have common ideas and phenomena that they know about, that we have in both cases decentralized endogenous controls of the system, but also we have unclear indicators and unpredictable outcomes, which they need to define, understand, and improve over time. But after all, they see that this is an attractive playground for them, and they are very keen to work on these projects in the future again. Thank you.
We can do one question during the swap. Then we'll switch over to next speaker.
Do we have a question?
You want to connect or?
So my question is, thank you, that was a really informative talk. I was just interested to know about the time constants in the modeling, because you have various systems, some react fast, some react slow. How do you deal with the complexity of time constants?
Does it work? No. So definitely time is an issue, right? And in this multi-scale modeling, you also need to multi-scale for time. So you need you want to be able to make one model that is solving all the issues that you have. But if you have some specific phenomena, you might want to zoom in on time. And if you have to something that you want to observe in the long term, you want to zoom out, and then you will make again some simplifications. What is the most important thing to mention is that we are talking about a state space update, right? So you have every time every action is taken, you have a new state, and which states or which update steps you define in the model is up to you. So whatever you want to observe, you can choose whatever you want to see.